Now I'm going to go over Lagoa forces, and this is going to be a pretty short video because there isn't really much to go over. It's pretty simple. Let me go ahead and replay. You notice as these particles fall down, they look like it's ooze or some kind of syrup or something like that. They're really falling down very slowly, almost like some kind of paste. Okay, and there's a reason for that. Well, there's lots of ways to achieve that effect, but right now what's really affecting my particles is my Lagoa forces. So let me open up the Lagoa add forces compound, show you some stuff here. The top is pretty much self-explanatory. It's got gravity. If you disable gravity, the particles are not going to fall or go anywhere unless you give it an initial force. It's on by default. Gravity is set to -9.8, which is a real-world value. I strongly recommend leaving the gravity alone at defaults. Don't change it unless you're purposely trying to go for some other kind of effect. Okay, so maybe you're trying to do a fluid in space or something like that. Okay, but for most cases you want to keep it on and at -9.8, but you're free to change that if you want. Air density is basically the resistance of the particles moving through a medium of air. Okay, it's not a vacuum. There's air molecules just like in real life, and they actually create friction with the particles as they pass through, and that slows particles down. Now I'm not sure why this is the case, but by default the air density in Lagoa is set a little bit too high. Okay, the value is 0.02 as you can see here, but I find that value is much too high. Watch what happens if I turn off the enable air density and I play this again. The particles now seem to fall more naturally. See that? But there's no air density, so it's almost like they're falling through a vacuum, and that's going to create some really quirky results, which is not going to look good later when you start working on more complex Lagoa effects. So you do need to have some air density to make the effect behave and act normal. Okay, but the air density right now in Lagoa by default, the 0.02, is actually much too high and makes it look like your particles are trying to fight their way through mud or quicksand or something like that, which is not good. Okay, so we also have the ability to enable air wind. Okay, and it's off by default, but we can turn it on, and I could choose a wind direction. So let me say I want some wind in the X. Let me choose maybe a value of 20. Let's see how that works out. And then you can control the intensity. I'm just going to hit play, and then I'm going to increase the intensity. And you can see the particles are now starting to get pushed off in the X direction, thanks to the wind that's being simulated here and is exerting itself upon our particles. And you can choose different wind directions. If you went with -20, it would just end up blowing the particles in the opposite direction, in the negative X. And you can control this air contrast curve down here to change the effect. So let me disable wind. It's off by default, so it's optional to turn it on. And then down here we have an extra force parameter, and basically this works just like the initial force from the emit node that we looked at in the last video. So if I want to give this more force in the Y direction, maybe make it -20. Let me rewind this. You notice the particles fall down really fast. So let me put that back to 0. So that's the Lagoa forces. It's pretty simple. And the cool thing is you can add more nodes here. Keep that in mind. So if I go over to particle nodes and I want to get myself some modifiers, I can get something like randomize around value, and I can go in here, plug this in, and I can randomize the air wind as well as the air density, the forces. I can do a lot of cool things. So I can plug this into the intensity, and now I can get myself a random intensity for the wind factor. So it could be a wind that blows back and forth and changes its intensity over time so it looks more natural and random. Okay, so that's pretty much the forces. Pretty simple, pretty straightforward.